Hello everyone, welcome back. This is part 6 of the Solid Design Principles tutorial. In this session, we will discuss dependency inversion principle and will understand the intention of dependency inversion principle usage. Please refer to the previous parts of the tutorial before proceeding. In the first session of the Solid introduction, we have understood that D in the Solid is acronym for dependency inversion principle, which is also known as DIP. The dependency inversion principle introduced by Robert C. Martin states that high-level modules should not depend on low-level modules, but both should depend on abstractions. It also states that abstractions should not depend on details, but details should depend on abstractions. To simplify this, we can state that while designing the interaction between a high-level module and a low-level module, the interaction should be thought of as an abstract interaction between them. Let's now understand what dependency inversion principle means and what kind of problem does this solve in the application development lifecycle. Before understanding the intention of usage, let's try to understand a traditional application architecture implementation. During the process of the application design, lower level components are designed to be consumed by higher level components, which enable increasingly complex systems to be built. In this process of composition, higher level components depend directly upon lower level components to achieve some task. This dependency upon lower level components limit the reuse opportunities of the higher level components and ends up as a bad design. From the illustrated diagram, higher level modules depend directly on lower level modules, and this does not follow the first point of the dependency inversion principle. Now let's take a look at a button click event example from the presentation layer that calls directly the employee save method of the business logic layer, which does some validation checks before saving the employee details to the database. This flow looks absolutely fine. However, we are coupling different layers as said earlier, and any further changes are complicated and cumbersome. Now let's see this problem with a sample code. Notice from the given code, the business logic layer is directly dependent on the lower level data access layer, and it's hard to perform any unit test on this code as both are coupled. Of course, we can do some amount of testing on the data access layer, but imagine if the data access layer need to be further extended to SQL and XML layers. If we need to do that, implementation to extend it becomes tedious and much more complicated. Hence, based on the dependency inversion principle, we apply an abstraction to decouple these layers. In order to achieve that, we introduce an interface that acts as abstraction so that both these modules are decoupled. This decoupling is demonstrated in the representation diagram, and further we can rewrite our code as shown on the screen. If you take a look at this code, based on the pictorial representation diagram, we have introduced the interface which is extended by the data access layer and referred in the business logic layer. Hence, we can say that iRepository layer acts as abstraction between these two modules. Adapter design pattern can be seen as an example which is applying the dependency inversion principle. That is, the high-level class defines its own adapter interface, which is the abstraction that the other high-level classes depend on. The adapter implementation also depends on the adapter interface abstraction. However, we are not going into the detailed discussion of adapter design pattern as it's out of scope of this session. For more details on the adapter design pattern, we strongly recommend you to refer to the adapter design pattern tutorial. In the next session, we will further discuss the implementation of dependency inversion principle using abstraction, dependency inversion or inversion of control, service locator, unity containers, etc. using some simple examples. I hope now you have a good understanding of why we need to follow dependency inversion principle. Thank you for listening and have a great day.